right? So you need to know when is it that we use this quotient property and when is it that we do what we call rationalize the denominator to simplify, right? Notice in this one here that if I put these all into one radical, right, the radical, the square root of 200 over 2, I'll put it all together, 200 x to the 5th y squared divided by 2x, right? When they're all in the same fraction, actually you can cancel everything that's in the denominator with something in the numerator. So by doing that, we don't have a denominator. We don't have a radical sign in the denominator anymore. And we've been told we can't have radicals in the denominator. So as a strategy here, putting them into one radical actually helps us get rid of that denominator. 100 x to the 4th y squared, which is 10x squared y. Right. But over here, if you can imagine, if I had them in the same fraction, would I be able to cancel anything? No. So it does not work for us to use the quotient property to put them into one fraction because we still have a radical in the denominator. So instead, we did this thing called rationalize the denominator, which means we're going to do something to get rid of the radical in the denominator. Do you remember what did we do in this kind of problem to rationalize the denominator? Because we did two different ways. Say what?
You multiply it by 2y.
The square root of 2y, right? Whatever is this denominator, you're going to multiply it by that divided by itself. Right. Now, you can do that because anything divided by itself is 1. So what you're really doing is multiplying times 1, which doesn't change the value of anything. But what do you get when you multiply the square root of 2y times the square root of 2y? 2y. It gets rid of the radical. So by multiplying by that precise thing, no more square root in the denominator. Okay. In the numerator, the square root of 3x times the square root of 2y, now you're going to use that product property again. What is that? The square root of 6xy.